In this lesson we're going to look at the double angle formula and look at how to rearrange it in terms of cos squared x and sin squared x. So we're going to look at a couple of proofs first. In this proof here we're going to rearrange to cos squared alpha. So the first thing I'm going to do is I'm going to swap sides. I'm going to write all of this side here on the right hand side and cos 2 alpha on the left hand side. The reason I'm going to do that is because I want cos squared alpha to be on this side for my subject. I'm then going to add 1 to both sides if you like, and then I'm going to divide by 2. So instead of putting a big line, the 2 in the bottom, I'm going to multiply by a half and use brackets. And that's us successfully rearranged this formula here from the formula sheet to get cos squared alpha to be the subject. This is not given in the exam, this yellow section. So if you're ever asked for a question involving this, like in the following slides, you have to rearrange it yourself. Okay, proof of sin squared alpha and the formula that creates. So firstly, I don't like the fact that the subject is negative here, so I'm going to take it over the other side and make it positive. I'm then going to subtract this because I want sin squared alpha on its own. And then I'm going to divide by 2 again. So a half bracket 1 minus cos 2 alpha, and that's my formula. Okay, let's look at how this can be used. So use the formulae for cos squared x and sin squared x to express each of the following without a squared term. So if we were faced with this in a multiple choice question, then you would look at your formula sheet and you would look to see the formula. So it would be cos 2 alpha equals 2 cos squared alpha minus 1, because we've got cos squared b there. And I would rearrange this. So I would add 1 to this and then divide it by 2 or multiply by a half. I would use a b though instead of an alpha here. So that would be my answer there. In the second example, we've got sin squared beta, but we've got 3 betas this time. But what I would do is I would write the formula out for sin squared beta first. And that was a half 1 takeaway cos 2 beta. Again, looking up here, you would take this over the other side, and then you would subtract this from 1 and then half it. That would be using the proof in the previous slides. Now, because we've got sin squared 3 beta, this means you've multiplied this angle by 3. So we need to do the same on this side. We need to multiply this angle by 3. So that becomes a 6. Okay, same idea down here. We've got cos squared 4 beta. I would write this formula out here for cos squared beta. And then because in this case we're multiplying this angle by 4, we need to do the same to the other side. So that becomes 8. Sin squared 5 beta, write this formula out first, rearrange from the formula sheet, then because we've multiplied this by 5, we do the same over here and that becomes a 10. Okay, last two examples. Express each of the following in terms of cos 2x. So that really means we don't want the cos squared beta there, we want to rearrange it so there's no longer a cos squared. So we can do that. We can rearrange from the formula sheet again to say that cos squared beta is equal to a half cos 2 beta plus 1. And then all we do is multiply by 3, because there's a 3 in the front. So to do that, what I've done here is I've used square brackets, because I've already got curved brackets there. Now to multiply this out, basically do this first, multiply the 3 by the half, and whatever that comes to, you can multiply the curly brackets with. So 3 times a half is 3 halves times that, and then that's 3 halves times cos 2 beta and 3 halves times 1, which is this. And finally, 4 sin squared beta, Again, rearrange from the formula sheet to get sine squared beta, and then multiply all of this by 4, using the same technique we just did over here with squared brackets. So this time, if we multiply 4 by a half and get our answer and times it by the curly brackets here. So 4 halves is 2, and then multiply through by the 2, so we get 2 take away 2 cos 2 beta.